Okay, this video is about rational functions and how to find holes. Now, holes will help you graph it because it's an actual place in the curve that doesn't exist. It's like a hole. So the line has to go through it, and it can help you kind of know where's that curve going. All right, so it'll be helpful, but you need to know about that because it does change your equation a little bit. So here's the steps to finding a hole. Write these down and then we'll go through some examples. First, you want to factor the top and the bottom completely. Right? Then you're going to cancel any common factors that you find. One that's on the top and the bottom, that represents a hole in the graph. So if you cancel those common factors and you simplify the equation. To find the x and the y coordinate of that hole, where's the actual hole going to go on the graph, you solve that common factor for x, cancel what's common, and then plug the x into what's left of the equation, what's remaining. Okay, I'll show you what I mean. So let's look at this. F of x equals x squared plus x minus 2 over x squared minus x minus 6. I need to factor these. So if I factor them, I get x plus 2 times x minus 1 over x plus 2 times x minus 3. All right, so it's completely factored. Now I look for common factors. These two are in common. That means there's a hole. Okay? Now to find the xy coordinate for the hole, I take that factor, set it equal to 0, and solve it for x. So I know the hole has an x coordinate of negative 2. Now, my equation is now simplified. That goes away, and the equation is x minus 1 over x minus 3. And that's what I focus on the rest of the time. Now, if this is my equation, I take that negative 2 and I plug it in. So f of negative 2 is going to be negative 2 minus 1 over negative 2 minus 3 is negative 3 over negative 5. And that gives me a positive 3/5. All right, so there's my coordinate of the hole. So yes, I have a hole, and there's the coordinate. Now, x-intercepts, remember the rule, set the numerator equal to 0 and solve it. So x is a 1, but this is a coordinate, so it's 1, 0. Vertical asymptote, you set the denominator equal to 0 and solve it. So x equals 3. Horizontal asymptote, that's Bobbio, Botno, eats DC. So let's look at our exponents. Exponents is 1 here and a 1 on the bottom. That means the exponents are the same. So I divide the coefficients. It's a 1 divided by 1, which is just 1. So it's y equals 1. Y-intercept, remember you plug in a 0 everywhere there's an x in the equation. So y equals 0 minus 1 over 0 minus 3, negative 1 over negative 3, or positive 1/3. So it's 0 and 1/3. All right, so now I have all my characteristics and I can graph this guy. All right, so if I graph it, let's put in these asymptotes first. Okay, I have a vertical asymptote at x is 3. I have a horizontal asymptote where y is 1. Okay, I know it intersects the y-axis or the x-axis at 1, 0. And then the y-intercept is at 0, 1/3. So that's just above the origin. Then I also know that there is a hole over here at negative 2 and 3/5. Now 3/5 is less than 1, so it's under the asymptote, and it's an open circle. And then I connect my dots. There's this curve. Figure that one out really quick. So I've established what's going to go on the left side of the asymptote. Now on the right side, I need to decide, is it top or bottom? So I pick an x coordinate over here, like 4, and I'm going to figure out what is f of 4. So I plug that 4 into this equation. 4 minus 1 over 4 minus 3. I get 3 over 1. So I have a point then at 4, 3. So where x is 4, y is 3, right here. So I know my curve is on the top of that asymptote. All right, so there's my shape of my rational function. Let's try another one. Same process. Start by factoring. If I factor the top, I get x plus 3 times x plus 1. On the bottom, I notice there's an x in each term. I can factor that out, and I have x plus 3. So there is a hole. Yes, there's a hole. So I take that factor, set it equal to 0, and solve it. I get negative 3. So the coordinate of the hole starts with a -3. If I cancel that out, what's left in my equation is x plus 1 over x. Now I take the -3 and plug it into what's left. So -3 plus 1 over -3. So I have -2 over -3, also known as positive 2/3. So I found my hole. Now x-intercept. All right, x-intercept, the rule says take the numerator, which is x plus 1, set it equal to 0, and solve. So I get a -1. So it's a coordinate, -1, 0. Vertical asymptote, you take any factors on the bottom, set them equal to 0. Well, this is just x, so it's just x equals 0. So I have a vertical asymptote at x equals 0. Horizontal asymptote is Bobbio-Botno eats DC. So remember, look for the highest exponent on the top and the bottom, compare them. They are the same. Exponents are the same. That's an eats DC, so I divide the coefficients. 1 divided by 1. So that means y is 1. And then the y-intercept, I take what's left of the equation again and put in zeros for all the x's. So I have 0 plus 1 over 0. And that's 1 over 0. That, my friends, is undefined, which means it does not even exist. Okay, so that tells me the graph is not going to cross the y-axis. So we're going to graph this. Asymptotes first. So I have a vertical at x equals 0. And I have a horizontal at y equals 1. X-intercept is at -1, 0. And I have a hole over here at -3 and 2/3. Remember, 2/3 is less than 1, so it's going to be really close to the asymptote, but not crossing it. Okay, there we go. The curve finishes out over here. Now, on the right side, I need to know is it top or bottom. So let's pick an x value, like 1. Really easy, 1. So I do f of 1, and I'm plugging 1 into my equation right here. 1 plus 1 over 1, which is 2 over 1. So I have a curve where x is 1 and y is 2. So this is at 1, this is at 2. So that means my curve is above that horizontal asymptote. All right? So that's that one graphed. Let me do one more example. Now, this one's a friendly one. It's already factored for me. So I can notice real quickly that there is a hole. And where's that hole located? Well, take the x plus 2, set it equal to 0, solve it. So the x coordinate is -2. And now I cancel this out, and I plug in the -2 into what's left of my equation. So f of -2 is going to be -2 plus 4 over -2 minus 3. -2 plus 4 is 2. -2 minus 3 is -5. So this is up -2/5. All right? So here's what's left of my equation I'm focusing on the rest of the time. X-intercept. All right? Take the numerator, set it equal to 0, and solve it. So at -4, 0, it's my x-intercept. Vertical asymptote, take the denominator, set it equal to 0. And that means it's x equals 3. That's the vertical line equation. Horizontal asymptote, Bobbio-Botno eats DC. Look, here's your leading powers of your exponents. They're both 1s. So it's an eats DC. Exponents are the same. Divide the coefficients. 1 divided by 1 is 1. And then a y-intercept. Okay, to do y-intercepts, remember the rule says take what's left of the equation and plug zeros in everywhere. So I have 0 plus 4 over 0 minus 3. So it's -4/3. Oops, there we go, -4/3. All right, let's graph these characteristics and see what shape comes to mind. All right, x-intercept 1, 2, 3, 4. Start wherever. Vertical asymptote is if x is 3. Horizontal asymptote is y is 1. Y-intercept at 0, -4/3. Now, -4/3 is really -1 and 1/3, remember? So it's a little bit more than -1. Now, where's the hole? The hole is at -2 and -2/5. So -2 and -2/5, This is 1 and this is negative 2/5 is less than 1, right? So it's way up here. So my curve is doing this business. Okay. Now on the right side, I need to know is it top or bottom. So if the asymptote is at x is 3, let's try 4. So I need to find out what is f of 4. If I plug it into f4, so I have 4 plus 4 over 4 minus 3. Well, that's 8 over 1. So I know the curve exists at 4, 8. So this is way up here. So I know it exists up here. So that means my curve is up here. And that's all I need to know. Now I know my general shape. All right, you try this one on your own, and we'll talk about it when you get to class.